All right, good morning, everyone. How's it going? Is that loud enough? Can you hear me okay? Yeah? Okay. Awesome. My name is Nathan Harvey. I hope you're here for Lumos Day. No? Okay, good. So this is the chef's training. Actually, this isn't the chef's training either, but I thought it was awesome that on the sign outside, they called it chef's training. So at the end of the day, we'll all be chefs, which will be awesome. It's not that either, I'm afraid. So if you're not on the Wi-Fi, just give it a minute, maybe. Are you on the Wi-Fi now?
Yes, ma'am.
All right, excellent. We were just waiting for him. So when you complain later in the form, like the feedback form, that we started 2 minutes late, it was his fault. It took him too long to get on the Wi-Fi. I see some guys in the back without laptops. They're probably not on the Wi-Fi either, but it's cool. And I promise not to single you out throughout the day. If you haven't already, you can grab everything I'm going to show you today from that GitHub URL, github.com/myname, which you have to misspell because my dad did. Surge, those are underscores, those aren't spaces between Surge and introduction and to and chef. I'll leave that up for a second while you curiously type that. You could just click the link. It would be easier if you did that from where you are, but I know that doesn't work so well either. Yeah, see what you can do with that notebook, right? Because I'm an exhibitionist, what we're doing is streaming this live to YouTube right now, because that's just what I like to do. If I can do something on the web versus not, I would rather do it on the web. And so, fuck it, we're gonna do it live. And there we go, there's the first F-bomb for the day also, so we got that out of the way. There may be more of those to come, and if it offends you, I'm sorry. And also, I'm just sorry, it's not gonna change. I may offend you further today. I truly am sorry, but I also probably can't help myself. Everyone had a chance to grab that URL there? Cool. Also my Twitter handle, if you want to follow me, because if you look at my Twitter handle, the tweet stream from me, I just tweeted the live URL for the stream that's happening. But here's the thing, don't watch the live stream because you're part of it. And it gets weird when you do that, especially if you turn on your volume and then it's echoey and it's not very good. Let's see, there were some prerequisites. I hope you completed all of the prerequisites. Those included to install the Chef DK. The Chef DK, DK stands for Development Kit. I've heard recently that sometimes when people at Chef say Chef DK, what people hear is Chef Decay, right? It's not that, it's Development Kit, DK, Development Kit. So hopefully you installed the Chef Development Kit. That's totally the wrong URL. I swear I updated that. Does it matter what version? It matters as long as it's like greater than 0.2.2, you're fine. Which is about a year old, so if you have a Chef Development Kit, it might be good. You should have an SSH client, and you should have a good text editor. You should have Git installed and a GitHub account. Now, if you haven't done these prerequisites, please don't do them now. And I'll tell you why. The thing that we're actually going to need today is an SSH client. So that's like the beginning and end of the prerequisites that you absolutely have to have for today to get through the class. So it's cool. I'm going to give you the rest. Except you might argue with me on the descriptor for text editor, because you might not find that it's a good text editor. You might find that it's just a text editor. That's cool. Some quick introductions. My name's Nathan Harvey. I work at Chef. I do a bunch of other things. This is my 6th year at Surge. I didn't even know Surge was going on. That feels like a lie, and I'll probably lie to you today. So that might, in fact, be a lie. But I think this is the 6th year of Surge, which is pretty awesome. How many have been to Surge before? All right. And how many have been to any sort of chef training before? Okay, cool. You may find this super introductory. Maybe good for you. I don't know. Maybe just fun. It'll be awesome. There's more stuff about me there that you can read, because you now have grabbed all of the slides. I did give you all of the slides, but there's a social contract that we have. Please don't work ahead. Actually, you can work as far ahead as you like. That's the truth. But when you work ahead and get yourself caught into a corner that you can't get yourself out of, you might not feel a whole lot of sympathy coming from either myself or any of the other assistants that we have today. So don't work ahead, basically. So we have some lab assistants today. Adam Left is in the back. Adam, would you say hi to everyone?
Hello, everybody. Good morning.
All right. So Adam is going to help as we do labs, and we're going to kind of mix this up today. What I want to do is get you a lot of hands-on, but the kind of the downside of that is we keep everything pretty fundamental, pretty rudimentary that we're going to do with Chef. So you'll get a lot of hands-on, but you won't see some of the more advanced features, the more really interesting features of Chef. So what I'd like to do is mix in a couple of demos throughout the day, and I'll have a list of things that we can show you, and you will decide which of those things we show you. And so Adam may show some stuff, I may show some stuff. Travis Spalding is here. Travis, would you say hi? Oh, he's not actually here. So he texted me earlier and said, I'm going to stop and get some breakfast. Do you want to join me? I did not. I mean, I wanted to, but I didn't. So he's going to show up and he will be well fed. He maybe didn't realize there were going to be bagels, or maybe he wanted bacon. I don't know. But the other lab assistants are you. So as you run into problems, what you can do is turn to your left or your right, and you can help someone else. And if you don't have someone on your left or your right, that's sad. But you can just turn around or talk to someone in front of you, and it's all good. So that's that. Quick show of hands, because I like to do science, and this is how we do science. We just raise hands, and then I tally the numbers in my head. How many of you consider yourselves sysadmins, system administrators, or operations people? Cool. And developers? You can answer more than once, by the way, so cool. All right. How many of you are DevOps? Okay, awesome. And business people? Okay, so only some of you got these answers correct. As it turns out, you're all business people. Because frankly, if you don't give a shit about what your business does, what you should do is quit your job. Because it's important to understand why you come to work every day. So we're all business people. I used to argue that you couldn't be a DevOps, but I gave up that argument. The internet won. It's cool. You can totally be a DevOps. And I love you for doing that. So that's awesome. Just one more question for you to get us started. Which version control system do you use? Don't answer yet. Do you use this one? Yes? Cool.
Can you answer more than one?
What's that?
Can you answer more than one?
Yeah, you can answer more than one. Yeah. So who uses this one? Yeah, of course. There's a problem with this one though, that when you use this, like, what do you do with the next time you need to change foo? What do you call it? Back one, right? Back one, maybe, but like we're back, right? It could be back. You never know. The problem with like that system is the time you need a second copy, like you realize I'm not doing computer science properly. It should be a zero-based index, so it should have been back to zero. And then so I'm going to fix that problem. So I change it. Do you use this version control system? Anyone use this one? This is totally better than that other one. Much better. But this version control system is lacking the most important command from every proper version control system. Do you know what that command is? Diff. Not diff, no. You could totally diff those two files. Not through the like cp command, but through you could diff those files. What's it missing? The most important version control system command. Every proper version control system has this command. It's blame. Right? So now, this is a solid version control system. I hope this is not the version control system that you use. Travis, how was the bacon? Amazing. All right. Everyone else, Travis, he just had bacon. He might not have had bacon. Travis, tell me you had bacon. Of course I had. All right. Honestly, what version control system do you use? Git? Yeah. What else do you use? Anybody use anything else? CVS? Is that what you said? Yes. Okay. You should use Git. You're old. No, you're not old. CVS is
SCCS.
SCCS? All right. So now we're going to see who can name the oldest version control system. Isn't this fun? Cool. So I usually tell people that you can use any version control system you want as long as it starts with Git, but it sounds like you all already got the message, so that's cool. So Git is where it's at. How many of you have experience with infrastructure as code or configuration management, like this general topic, and have like played with those tools? Awesome. And how many of you with Chef? So I said there was one more question. I also lied. Okay, so those of you with experience with Chef, when I lie later, just mum's the word. You don't have to tell everyone that I'm lying and telling them bad things about Chef, because I'll correct myself later, or they don't need to know yet. It's cool. Everyone else, everything I say is completely true, and you can trust me all the time. Today is just going to be an introduction. So we have a day from 10 to 5 today. We're going to break for lunch. We are not serving you lunch though, but there's plenty of like lunch options right here in the biodome that is the Gaylord. Let's see, what else? Oh, right. We'll take breaks throughout the day, including lunch. But here's a thing about you that I've recognized already. You're all adults, so if you need a break, get up and take a break. It's cool. This training was included, I like to say it's free training, but it's not. It was included in the price of your surge ticket. And as far as your manager is concerned, they can ask me and I'll say that you stay here the whole day. So if what you'd rather do is go ride the big wheel, because that looks like fun, you can totally go do that. And I'll say that, yes, that person learned Chef today and they were awesome. They were the best students in the class. I'll tell all of your managers that. So if you are here with a coworker, like, we're gonna have to find a way for me to not lie to you, well, to say the right things. Yes, so we're streaming live, so hello to the internet, which means if you ask questions, even though everyone in the room will have heard your question, likely, I may repeat the question because the people on the stream might not. But the other thing that's cool about that is that there's a recording of this that you'll be able to go back and review all of the stuff. And you can cringe at the question that you ask. Like, why did I ask that question? Of course, that was obvious. No, I'm kidding. You should ask all the questions that you want. There are no stupid questions, so just ask away. I also want you to like interrupt me, throw things at me. I was supposed to update this agenda slide because I changed all the slides last night, and I always save the agenda slide to be the last one that I update, and I usually forget to update it. So the agenda might look something like this. We're totally going to do hands-on Chef. We'll do some demos of things that you can't put your hands on because like the setup would be too much for us and we only have a day. And what I want to do is answer any questions that you have. And we have great chef experts in the room, not only including myself, Adam, and Travis. There are other folks here that use Chef that can answer questions. I think I said these words. There's very few times where all we're going to do is look at slides, and I will never read the slides to you, except for the ones that I already read. So yeah, it's kind of repetitive. So I hope you got all of that. Let's talk about Chef. So I'm also making a quick assumption here, and let me just level set on what that assumption is. We all have a basic understanding of what Chef is and why you might use Chef. Does that make anyone feel super uncomfortable, like I'm already lost? Okay, so that means, yeah, you're already lost, good.
Yeah. I would like to hear a short introduction.
A short introduction?
Yeah.
Sure, I'll give you a short introduction. So there was a prerequisite that was watch a 45-minute video that was a short introduction. What I am not going to give you is a 45-minute introduction. What I will give you is like the 3-minute introduction, and if somebody will start a timer, that would be awesome, so I'll stop talking. So Chef is a tool that allows you to manage your infrastructure as code. So what the hell does that mean, to manage your infrastructure as code? What you're going to do with Chef is you're going to write code that describes the desired state for your infrastructure and for your applications. So it's essentially an automation platform. You can use it to automate the provisioning, the configuration, the maintenance over time of your servers.
Similar to Puppet and Docker?
Similar to Puppet, yes. Similar but different. And then you said similar to Puppet and Docker, and I would say that Docker is not at all like Chef. Docker is not at all like it's a different thing, it's a different class, yes. So if you understand what Puppet is, you understand what Chef is, at least at the high level, yeah. Good? Awesome. All right, thank you for admitting that you weren't sure, because you know, sometimes it's hard to be the only person who raises their hand. Cool. So with Chef, we're gonna write code. That code, the very sort of core piece of that code is resources. So with Chef, we're going to describe resources in our code. And a resource is a piece of the system and its desired state. It's always these two things sort of wrapped up together in a resource. So what does that mean? A resource might be a package that should be installed. It might be a service that should be running or enabled to be restarted on reboot. It might be a file, even though it says service, it might be a file. So there will be typos in the slides. I will be sure to point out every single typo so that I feel really shitty throughout the day, just so we're clear. You might have a cron job that you want to configure, a user that you want to set up, a DSC resource that you want to control and manage. How many of you have used DSC before? All right. Awesome. So there's like 2 Windows admins in the room, is what you just told me. That's cool. If you are a Windows admin and you haven't used DSC, then you should get on the train and use
What is
DSC. DSC is desired state configuration. It's a component of Windows. So use PowerShell, use DSC. If you're in the Windows world, you have to do those things. Windows is getting cool again. It's kind of awesome. You could manage a registry key, because also Windows. So it's a piece of the system and its desired state. You can find out about all of the resources that Chef provides out of the box at this URL on the docs site. But also with Chef, you can create your own custom resources, which is a fairly easy thing to do. So easy, in fact, that we are not going to cover it in our intro to Chef. Not because it's that easy, just because we won't have time to write our own. Okay, now comes the part with the typey. So what I'd like you to do is, I need your assistance here. I have a deck of cards. What I'd love for you to do is take a card and then like pass them to your neighbors until everybody has a card. I'm gonna run out very quickly here. All right, I know. So don't worry, there's plenty to go around. I can help distribute them back, except they're all going that way, so I can't really help you. So that failed. All right, once everyone gets a card, what I'd like you to do is go to this URL. Once you go to this URL, it should become apparent what the card is for. I don't know if anyone is watching this stream. If you are and you hear things good, well, and it's coming through, it would be awesome if you tweeted at me and said, hey, that live stream of Chef training is pretty awesome. Does this URL work? Slowly, slowly, slowly. Okay.
Is it supposed to work?
It should work, yeah. It's working for some people, right? Yeah, awesome.
I got forwarded now. I'm trying to get through this.
All right. Here's the best thing about technical conferences. You know that you can be angry about something at every technical conference you go to, and that thing is constant. It's the Wi-Fi. Every technical conference, you will be pissed off at the Wi-Fi, guaranteed. And if you're not, then what you should be is really happy about that technical conference. Probably the content will be shitty at the conference. The Wi-Fi is good, content shitty. It's like an inverse relationship. That's not really true. What if the Wi-Fi is really good tomorrow? And you're like, man, oh no. Okay, is it good for you now? All right. Has everyone sorted out the magic that is this gist that I've given you and the reasons behind the card? Okay, what I'd like you to do is take your IP address and I want you to SSH into your machine. Now, that's going to be rather difficult for you to do because I haven't told you how to SSH into that machine, what the credentials are. But in order to do that, I don't want to tell the internet Okay. So I'm going to do the same thing that you're doing. If I can, yep, I'm going to grab that there. Okay, so give me 1 second. I want to make sure that everybody is good here. Talk to myself. Okay, so you launched Putty or your terminal and you typed in something like this. Can everybody see that? Can you see that okay in the back? Is that large enough? Yeah, Adam, good. And so when you do that, the first thing that it's going to ask you to do, did it ask you to verify the authenticity of your host? Yes, it didn't ask me. Maybe I've logged into this one before, because I know I have. So how do you verify the authenticity of a host? This is Surge, after all. We should do this properly. How did you do that? You typed in YES and then hit the magic key. Awesome, that's the right way to do it. Rock on. Those of you that are using Putty, you can't type in YES because it's Windows. So you make the clicky of the button that says OK or yes or author. I don't know what the button says. It's been too long since I've puttied. And then you give it your password, which we're not going to say out loud. Luckily, I remembered mine, so that was good. Now comes it's maybe a little bit awkward. This is a part that I don't have slides to walk you through the lab. Most of the labs we're going to have, like, I'll show you the code that you're going to do. Sometimes you'll just watch me type. This is probably the most critical lab that we're going to do today. What I need you to do is touch yourself. Let me restate that. So what I want you to do is type in the word touch and then a space, and then I want you to type in your first name and last name just all munged together as one string, but not YOURFIRSTNAME, right? Like, so kind of like what I'm doing, except different, right? So I'm gonna touch Nathan Harvey. You should not touch me, you should touch you, and then hit the magic key, which is enter. And then when you've done that, what I'd like you to do is just put your hands on your head. Because this will be funny. I should take a picture of you all with your hands on your head. That would be awesome. So, yeah, now you're just going to wave. You're like, nope, all right, everybody keep your hands on your head because we are going to take a picture. So, all right, good. Thanks, Adam. This is why I have assistants. Now what I'd like you to do is LS and then hit enter. And what you should see is two things. You should see the word cookbooks and you should see your name. If you see someone else's name, what needs to happen right now is the two of you need to step out those doors, fight to the death, one of you may return. Okay, here's the other thing. I mentioned we have this social contract. I gave you all the slides. You're not going to work ahead. Here's the other thing that we're all going to agree to. We are not going to fuck with each other's machines. We all know how to get into each other's machines. We all know the credentials. Don't mess with your neighbor. You could do, like, obviously you can, because as it turns out, one of the things that I've done on this machine is I've given the chef user passwordless sudo access, so you basically own that machine. You can do what you like with it. What I request that you do are chef things that have to do with the labs that we're going to cover over the remainder of the day. So what I want you to do is think about this thing as if it is your workstation. There were prerequisites that hopefully you did, but in case you hadn't, what I'm going to do, what I've done here is give you a sane, not that your laptop isn't sane, but like a known configuration. This is your workstation. So this is where you're going to argue with me about the good text editor. So Vim, Emacs, and Nano are all installed here. You can use any of those three that you like. And if you just got super nervous, like you just said I have to use Vim, Nano, or Emacs, it's cool. Your neighbor will help you, or one of us will help you, or you can just watch. It's fine. Those of you that don't have laptops, if you have an SSH client on your phone, you can probably do the whole class from your phone. I wouldn't recommend it necessarily, but it could be a lot of fun. Like, you could walk out saying, man, I chefed from my phone all day. That's like pretty awesome. Let's see. I think I have slides that talk about what I'm supposed to talk about next. So it's cool. We have a workstation now. So that is your workstation. It's up in the cloud. We verify the authenticity. So if you run this command chef -- version, you'll see that I've installed version 0.7.0 of the chef DK, I think. Is it 7.0? Cool. You can see that you have passwordless sudo access, which means that you can do anything you want on this box, including destroy this box. When you break it, it's maybe I'll help you fix it. We'll see. All right, so when you get a new workstation, when you start a new job, there are two things that you have to do with the laptop that you get. The first thing you have to do is make it productive. We've made it productive for you. It's a working system. The second thing you have to do is make it fun. That workstation is boring. It can't tell you what the cow says. So we're going to find out what the cow says, and we're going to use Chef to do that. So you'll be able to carry on a conversation with Henry. I'll show you Henry in a second. I'm sorry?
We should use Ansible for that.
We should use Ansible for that. Why should we use Ansible for that? This is a Chef training.
Because Ansible outputs the result of cow state.
Ansible does what?
Does the output on using cow state?
Oh, Ansible does the output using CalSay?
Yes.
We could totally write a Chef thing that will have the cow tell you the Chef output also. Yeah, no problem. We can totally do that. We are not, I mean, you can totally do that. We are not going to do that as a group today, but we do want to see what the cow says. So we're going to use this little application called Chef Apply. Now I want to talk to you about Chef Apply because remember what we're talking about here are resources. Resources are those things on the system and their desired state. It's the fundamental thing with Chef. We're going to use this tool called Chef Apply, which comes as part of the Chef development kit. It's not the thing that you're actually going to use when you start running Chef in production, but it's a good way to explore resources. So I'd like you to run this command, and you'll have to type it in, make sure that you get the quotes right. I'm gonna stop talking for a second while you type. So Chef Apply is this little application. One of the things that it can do, like you could run Chef Apply -- help, and it would tell you what it can do. One of the things that it can do is it can execute a resource, and you can pass that resource in as part of an argument on the command line. So the -E is going to say execute this thing I'm about to pass you in on the command line, and we're saying package CalSay. So have you done that? And you hit return, and it did a thing. So now what I'd like you to do is type this in at your command line. You can type in CalSay, and then in quotes, hello Serge. And the cow should tell you, hello Serge. And make sure you only type in hello, comma, Serge, because otherwise the lab will break. Everybody's cow talking back to them now? Awesome.
Do I have a non-same state now?
What's that?
I missed out the comment. Do I have a non-same state? Do I need new machines?
You missed it, yes. Yes, you misspelled the comment. We shall destroy your machine and provision a new one for you. That's how you configuration manage. Yeah, if you have a typo, blow the thing away. All right, so that's super fun. Now we have a working workstation and the cow can talk to us, so it's fun. So resources within Chef. We're going to describe the desired state of the system. We don't need to tell Chef how to get there. So if you look at your output, you'll see that Chef used a resource under the covers called yum package. So it sorted out what operating system we're on. Except yours didn't use yum package, because what did yours use? I tell you, my slides, every bit of code on my slides compiled, so it's all good. So clearly I built these slides with a different operating system, but it was the same command. That's weird, right? That's pretty cool. So Chef kind of abstracts away the details of, do I need to use apps to install a package or yum to install a package or what? Chef figures that out for us. Let's see, what else do I have to say? Oh, so what happens if you hit your up arrow twice? What happens when you do that? Yeah, you go back to the command. It said like sudo chef apply -e CalSay. So it's funny that that's what it does, but sometimes when I teach introductory courses, people don't know that the up arrow, like I just changed someone's life. But think about it, right? Think about the day you learned about the up arrow in your shell and how that changed your life, right? So there might be someone in this room for whom their life has just now changed, and they, like, today you became a professional sysadmin. You learned up arrow. And we'll teach you like Control R later. Like that's advanced sysadmin stuff. But if you get back to this command, it's not just the up arrow that's interesting. What happens when you actually rerun this command?
To date.
Yeah, it tells us that it's up to date, so it does not reinstall the package for us. So Chef works in what I call a test and repair model. Test and repair. So all of our resources are going to follow this model. So for example, if we said install the package Vim, Chef would run a test. Is Vim installed? If it is installed, Chef will do nothing. It will just move on to the next resource that it says that we're supposed to configure. If it's not installed, however, it will install it. So it will repair the system to bring it in line with its desired state. So we could rerun this command over and over again, package calstate, package calstate, package calstate. And what that will do is Chef will inspect the system. Is the package calstate installed? Am I in line with my policy? If so, I'm done. If not, I'll take whatever action is required to make the system in line with policy. If you understand that, you understand how resources work, and you understand everything that you need to know about writing Chef code. So now we can all go ride the big wheel. That's not true. We're going to do more stuff, of course. But everything else is kind of built on top of this idea of resources. So the resources are the fundamental building blocks within Chef. A resource is a piece of the system and its desired state. Each resource, when the Chef client encounters it, the Chef client will execute a test and repair pattern or model on that resource. Is it in the desired state? If not, get it into the desired state. What questions can I answer for you? Yes.
Is the repair step just like if it's outdated, it will update?
So the repair step is if it's not in line with policy. So the reason I'm like rephrasing your thing is because I'm being a pedantic jerk. So if we had said, like in this particular case, each resource has an action or a declared desired state. In this case, the default action is to install it. So it will make sure that the package is installed. You said update or like upgrade. It will not, in this case, look to see if there's a more recent version of that package. It would only do that if we said to upgrade that package. Does that make sense? Okay. And I don't know if that was the question you were asking or not, but I feel like I've answered your question. Okay, great. So there are a bunch of resources that we can use within Chef, and we're going to use some of these throughout the day. And I encourage you to just explore them on your own as you like with Chef Apply or later with recipes. Yes?
What if you don't want to use the default package manager or a different version of software?
Sure. So if you don't want to use the default package manager and you want to use a different thing, there's let me actually pull up the docs. So let's take a look so I can describe it with things that you can look at, not just with my words. That's fun when you screen share on a Google Hangout and you share your whole desktop and then you inception on that thing. So, but that's not what we're here for. I mean, that was fun, but definitely not what we're really here for. So let's go ahead and look at, so let me describe what I've done. I don't like to do things without telling you step by step what I did. I went to my browser and I opened up docs.chef.io. Down at the bottom of that page, there's a list of resources. The next thing I'm going to do is click on the package resource, which is right here. You can also click on the single page resources and providers to see them all on a single page. But I'm going to click on the package resource. It was easy to do while I was over there, and then I had to find it again. Okay, so first, there's the package resource, which is kind of a generic resource, but it has a bunch of more specific resources that you could call specifically. So if what you wanted to do was make sure that you were using apt, or make sure that you were using yum, You could call young package, you could call apt package. The other thing that you can do though, if we scroll down here some, I'm gonna scroll past a bunch of stuff, including the actions. Let's see. So there's an attribute here called provider. And let me describe what a provider is. So with Chef, we have resources. A resource is a thing on the system and its desired state. We're going to write those resources in our recipes. With every resource, there's also what's called a provider. And I like to think about them as the resource is the interface and the provider is the implementation. So the provider, the resource basically, when we said install Calce, the resource said, hey, provider, package provider, install Calce. That provider has code that says, what operating system am I on? What's the default package manager? I'm going to use that default package manager to install this package. But of course it tested to see if the package was there first, but that's how it got there. So you could override which provider it uses by specifying a provider when you declare that resource. Awesome, great questions. Oh, don't worry, I'll tell you when you have a bad question also, just so we're clear. So in addition to all of these resources that come built in, you can declare or define your own resources within Chef. So if you have something that doesn't fit into the model that Chef gives you, or you find yourself needing to do the same thing over and over again with a couple of resources, you could merge those together into one custom resource. So our resources are the fundamental building block. We're going to take our resources and put them into recipes. So a recipe is really just a collection of resources. So let's go ahead and look at how that would work, and then we'll do the recipes, and then maybe we'll take a short break. So we're going to kind of have this very simple problem that we're going to solve throughout the day. But we're going to use this problem to look at many of the tools in the Chef ecosystem, including our test tools and things like that. So our problem is we need a web server configured to serve up our homepage, and we'll know we're done because we can see our homepage in the web browser. So when it comes time to write your Chef code, the question that you need to ask is, what's your desired state? Where do I want to get to? You don't necessarily need to think in the specific details of like, what steps do I need to take? What you want to do is declare your desired state, or write that out in your recipes. So our desired state is we see our homepage in a web browser. So what do we have to do to get our homepage working in a web browser? What sort of resources do you think we're going to need? A web server, right? So which web server should we use? Nope, we're going to use Apache. I don't know why you want to use Nginx. Yes, we should use Nginx, you're right. But it's easier if we use Apache, and we're going to be easy and lazy today, and we're going to use Apache, not Nginx. Is everybody okay with that? Cool. Nobody ever got fired for picking Apache, right? Did you? Yeah? Okay, cool. Nginx, probably what you actually want to use, but like Apache's, and like if you're an Apache contributor, I love Apache, it's awesome. I love Nginx too, like whatever, it's all good. So we're going to need an Apache web server. So what resources do you think we'll need to get that onto our system? We'll need a package resource, yeah. What else might we need? A service resource, right? So once we've installed Apache, we should maybe start Apache. And then we want it to serve up our homepage. What is our homepage? It's going to be a file of some sort, right? So those might be the three resources that we might need. A package resource, a service resource, and a file resource.
User roles?
What's that?
Users?
Users? You could use users, but for our simple case, like you can, but we're not going to. We're going to keep things just minimal requirements are going to be met. We're going to be as lazy as we possibly can be and do as little work as possible while doing as much typing as you possibly can. Awesome. So recipes can do, so a recipe is a collection of resources. So we're going to take all of those resources that we just talked about, the package, the service, the file, we're going to put them into a recipe together so that we can just run that one recipe. So let's do this. Let's create a new directory. What we really should do is use chef apply to create this directory, but you know, it's cool. You can like manually create this directory, it's fine. Just in your home directory, we're going to create a directory called Learn Chef, and we're going to call that directory Lab 2. And then we're going to move into that directory, cd into that directory. And then we want to, before we write anything, we need to make sure that we actually have to write something. So let's curl localhost. Let's make sure that a web server isn't already installed and configured on this machine. What you'll find is that it's not. So let's go ahead and open up this file in that directory. So in Learn Chef Lab 2, we're going to open up a file called apache.rb. So your recipes that you're writing are, frankly, they're written in Chef. You might say, well, that's a .rb, so it must be a Ruby file, to which I would say you're right. But it's really, you're writing Chef. Chef is Ruby. When you write your recipes, you're writing Ruby. So you have the full power, the full access to the Ruby programming language as you write these. But Chef provides a DSL or a domain-specific language on top of Ruby or built into Ruby here for Chef. So for example, if you were to write just a straight Ruby file and you wrote package Apache 2, without loading the Chef libraries, Ruby would know what you meant. But because we're in Chef, it knows how to speak package. So I'm going to do the same thing here. I just need a second to do that though, because I need to switch over here. Call this Lab 2, is that right?
Yeah.
Awesome. Oh, what editor did you use to create that file? Shout it out.
Yeah.
Vim. Who used Emacs? Wow, all right, that's cool. That wasn't a judgy wow. That's cool. Okay, so we said, what did we say? Package Apache 2. Thanks, Adam. How many of you were Ruby programmers 45 minutes ago? How many of you are scared of Ruby? It's cool. It's cool. I'm going to teach you all the Ruby you need to know for Chef. That's a lie. I'm going to teach you all the Ruby you need to know for Chef for today. I will definitely teach you all of that. So the first bit of Ruby I will teach you is that we have a string here. In Ruby, strings will be enclosed in quotes. They could be double quotes or they could be single quotes. It only matters when it matters. Usually it doesn't matter, but sometimes it does. Right now, it doesn't matter if this word, Apache 2, that string, it doesn't matter if that's in single quotes or double quotes. And those, like earlier this morning, the people that raised their hand and said, I know Chef, and I told them keep their mouth shut if I lie. All of you people that raised your hand and said I'm a Ruby developer, keep your mouth shut when I lie about Ruby also, please. If you do that, I will be happy and I will buy you a cup of coffee right outside the room. And if you open up your mouth and say that dude is lying, I will ban you from the coffee outside the room. And if you don't drink coffee, then you can call me out. Also, as we go through the day, when I make with the typey, I am likely to make typos. You have two choices when I do that. You can wait and watch it fail and laugh at me and point, or you can call me out and say, hey, yo, fix that thing because you spelled something wrong. Sometimes, you know, maybe someone will do both. It's cool. All right, so package Apache 2. What's going to happen when we're not going to run this yet, but what will happen when I run this? What will Chef do? Describe it to me in excruciating detail. Who would like to do that? Yes.
It is going to check if Apache is installed in the server, and
yes.
if not, you will download it and install it.
That's exactly right. So it will check to see if it's installed. If it's not, it will download and install it. And the reason that it will download and install it, actually, I'll come back to that in a minute. So we said that we're going to need Apache installed if we want to serve up our homepage. Actually, some of you said we need Nginx installed, which is cool, but we're going to do Apache anyhow. So we're not going to do that yet. we're not going to do that. All right, we're going to do this though. We're going to skip ahead a couple of slides and write some other things because I hate the way the Apache 2 package works, because what I want it to do is fail, but it's not going to, so we're going to do this anyhow. So we're going to write more code into that thing. We're going to write a service resource where we start the service Apache 2. So I'm just going to leave this up here for a second while you type it, and then I'll talk about exactly what we're doing, because I have to teach you more Ruby. And more Chef along the way. Thank you for coming. That was kind of rude of me, I'll admit. Like, it's cool. If you want to leave, I won't call you out like that. I feel bad. I feel bad. It's cool. Okay, so
He just didn't know about the package resource, but he got everything.
yeah, right. What? Oh, it's the package resource. I got it. Golden. Right. Yes. He's automated everything except the yum install portion of his provisioning. So now he's good.
That surge edition paid for itself.
So what I didn't mention this morning is my goal for us over the course of the day is first that you have fun, second that you learn some Chef, and it's definitely in that order. And so if you aren't having fun yet, or if you haven't found anything to be humorous at all yet, it's not going to get any funnier. This is the brand of humor that we have in the room today. If you're enjoying it, you should totally stay. If you want to leave, it's okay. I might not take it personally, so it's good. All right, let's talk about what we just did here. So we said package Apache 2. It's going to check, is the Apache 2 package installed? If it's not, it's going to install it. And then we had service Apache 2, but we gave this an action of start. So let's go back to the docs and figure out why we didn't have to do that for package. So you can just look here with me, or you can browse back over there. So in the package resource, I skipped past this section called action for the package resource. And you'll see that we didn't describe or declare an action for the package resource because the action of install is the default action. It says default there. So without declaring an action, the default action will be used. If you were to look at the service resource, you would find that its default action is nothing. It's this one here, :nothing. So we have to tell the service resource that the desired state for that service is that it should be running, or it should be started. So we say start. Now, I want to talk a little bit about the code, and in order to do so, I'm just going to write the code myself. So the service resource, and this is, I'm going to talk about Ruby here. So the service resource looks kind of like the package resource. All of our resources look the same. They're going to have the type of resource that it is. So whether it's a package or a service or a user or whatever, we have a package here. And then we have a string that's going to be the name of that resource. So ours is going to be Apache 2. And then when we need to specify attributes or actions or other things about that resource, like we want to give it a further definition, what we do is we wrap those attributes and actions into a block. Now, a block in Ruby is things that fall between the keywords do and end. Now, you can think of do and end as curly braces if what you do is program Java all the time. You cannot use curly braces. You will use do and end, but you can think of them as curly braces if that helps your mind understand what's happening here. So between the do and the end, we're going to specify our parameters and our actions and whatever we want here. So we have this thing action, and it was :start, which is weird. Like start feels like a string, but it's not in quotes, and it starts with a colon. In Ruby, we call this a symbol. What you don't need to know is what we call it. So you can forget that little nugget of knowledge. You might ask, what is a symbol? In Ruby, a symbol is a memory efficient way of storing an immutable string. And if the words I just said were too fast or you didn't quite comprehend them, that's cool. You don't need to know that either. So you can lose that from your brain. The Rubyists in the room maybe would argue that I have to tell you more things about the symbols. I'm going to tell you one more thing about the symbols. If I use a symbol, you use a symbol. Period. That's it. That's all you need to know about symbols. The action for any resource will always be a symbol, or except when it's not. But it's always a symbol. Sometimes it's an array of symbols. So there might be multiple actions that you have on a resource. Now, how many of you have used Puppet before? Awesome. Sorry? I asked how many have used Puppet before? All right. So for a minute, I'm going to tell you why you should use Puppet and not Chef. And it's weird because I work at Chef, and I'm going to tell you why you should use Puppet and not Chef. And there is one very, very compelling reason. So how many of you speak and read English in the room? I expect all hands to go up, and if not, then speak and read English. Yeah? Yeah, okay. Well, hesitant. So when my English reading brain sees this keyword action, the way I interpret that is the system is going to do something. It's going to take an action, and the action it's going to take is that, to start. But does Chef start a thing when we run this? Yes, no, or maybe? Maybe. If the thing isn't already started, it will start that thing. But if it is already started, it's not going to take any action. It's not going to start that. This is the reason why Puppet is better than Chef. In Puppet, that keyword is ensure. Think about that. If that said ensure, start, like it would make so much more sense. It would be so much better. So that is the reason to use Puppet, not Chef. That they picked a better keyword there for their DSL. Sometimes I forget that I'm live streaming. So we use action. Don't think of the word action like it's going to do something. Think of it like this is the desired state for that resource. Now, there is one other thing I have to teach you about Ruby. So that action, that keyword action, is indented a little bit. For the Rubyists in the room, does Ruby care about that indentation? It does not. Do you know who cares about that indentation? I do, and all of you should. The interpreter, Ruby doesn't care. When you write Ruby and you need to indent something, you indent that thing 2 spaces. It's not a tab, it's not 4 spaces, it's 2 spaces. It can be a tab if you've configured your editor such that when you hit the tab key, it inserts 2 spaces. Period. That's it. Only 2 spaces ever. I may sound a little harsh when I say that, but trust me, it's right. The real thing is what you have to do with your teammates is agree on how you write code, because the thing that sucks more than anything else is a commit to your source code repository that changes functionality and corrects the spacing. And it does both of those things at the same time. You should punch the person who made that commit. I give you permission to do so. All right, so it's 2 spaces. There's a symbol, strings are in that, do in the end. What question's going to answer for you on this? All right, let's apply this. Let's make this happen. The thing that we're going to do is sudo chef-apply. Sorry, my text is too big. It's going to wrap. Yours probably isn't, unless you're old like me and need really big stuff. Last time we did a -e and we passed in just standard in. We don't need to do that. We're just going to give it a recipe. So our recipe is called apache.rb, and we're going to run that. And so this is going to do 2 things. It's going to make sure that our package is installed, and then it's going to start our service. But, you know, it's Ubuntu and it's Apache 2. So when you when you install Apache 2, clearly what you wanted to do also was start Apache 2. So the package handles that for you. Thank you, Apache 2. I love you. But it's important, it's good that we declare that in our recipe anyhow, just so that it's very clear. Like intention revealing, those are words that you hear sometimes with Ruby. It's intention revealing code. We want that service started. So now what happens when you curl localhost? Oh, you get a bunch of stuff back. It's cool. If you don't like curling and like you want to see it because you prefer the visual thing, not the typey thing, you could totally open up your browser and go to your IP address, and you should see the homepage for your thing. But the problem is, I said we wanted our homepage. We didn't want the default "it works" homepage. Although, like, that's a pretty cool page. It works. Cool slides that I should have talked to you about. I think we did all of those things. It's working. So curl happened. And we're not quite there yet. The web server's up and running. The default homepage is being displayed, not our homepage. So what resource should we use for our homepage? What do you think? A file. A file would be good, yes. So there's a couple of different resources that manage files on the system. We're going to look at least 2 of them today. There's one called a cookbook file. That's not what we're going to use. There's one called a file. There's one called a remote file. And there's one called a template. We'll look at a couple of these today, at least file and template. So we're going to use the file resource. Here's what I'm going to test. I'm going to test your knowledge. I'm not going to show you the code. I'm going to write down a requirement for you. Sometimes I like to go off book, if you will. So I'm going to say the file at var www.html index.html should exist and have the content here. This is your requirement for now. Oh, sorry, I made part of that go off the screen. I want you to update your apache.rb to make this happen. I'm not going to tell you how to do it. I mean, I'm going to tell you how to do it, but I'm going to let you figure it out first.
Are you gonna go to all of the folders and check to see who actually did it successfully?
Yeah, and then I'm gonna run a script. I'm gonna open up 50 tabs in my Chrome, and I'm going to see who did it. And if you left off the comma, I'm gonna take points off of your final score. If you have hello as lowercase, also deducting points. Also, none of that is true. And so after you've updated the apache.rb, go ahead and rerun sudo chef apply apache.rb, and hopefully it will fail and throw an error at you. I say that because then you can learn more, but it might work. When yours fails, if yours fails, just let us know, Adam or Travis. Travis went back for more bacon, I think. Or myself, we will come and help you. Or you can also turn to your neighbor and say, hey neighbor, my thing is not working. Also, if what you're doing is reading your email right now, it looks to me like you're inspecting a stack trace or something. So I'm not gonna move on until it's kind of clear that it seems to be okay for most people. Everybody's homepage working properly now? Yeah? Awesome. I won't make you put your hands back on your heads yet. I'm going to go ahead and make my Apache recipe do the thing. And then what you can do is you can compare yours to mine and see if we did the same thing. So I'm going to do file var www.html index.html. It's sometimes hard to type and talk at the same time, but I try to do it anyhow. And then I'm going to say action, create, and then I'm going to say content. How's that look? Does that look like what you did? What did you do differently? Because I bet you did something differently. Yes?
Well, I was following the documentation, so it was changing the mod.
Oh, you changed the permissions on the file too?
And the define owner as web admin, then it fails.
Oh yeah. If you define the owner as web admin, it will totally fail. Why does it fail if you define the owner as web admin? Do you know why? Because the user doesn't exist. So you could create that user, and then you'd be better. Yeah. What mode did you give it? What permissions did you give it?
0755.
0755. Yeah, cool. What else did you do differently? Yes.
No action.
You didn't include an action. Okay. That's cool. So like that. Except not like that, because you said no action, so you didn't write the action and comment it out, because that would be stupid. Also, but it's a good way to teach you a little bit more Ruby. So in Ruby, the hash mark, or the octothorpe, but not the hashtag, is the thing that you use to denote a comment. So in Ruby, a comment starts at the hash, and it goes all the way until the end of the line. How do you make multi-line comments in Ruby? I hope a Rubyist answers that question. How do you make multi-line comments in Ruby? Yes.
Lots of hashes.
What's that?
Lots of hashes.
Yes, you put a hash at the beginning of multiple lines. That's how you make a multi-line comment in Ruby. There is another way, but no one ever uses it, except the people that do it, and you should hate them like I do. Not them, their code. They are not their code. Multi-line comments means you have a hash in front of multiple lines. Spot on. You get a gold star for today. Awesome. Is your boss here?
No, he's not.
Awesome. Is it
No,
Ramez?
it is.
Yeah, I'll make sure he knows that you were the best student in the class. I'll do the same for anyone else also, except the other people that work for Ramez. I can only say one person to him, or get him drunk and then tell him other people also, so it's fine. Did you do anything else that was different? It's cool.
I started to use cookbook file instead of file, which is the
You started to use cookbook file instead of
I
file.
didn't finish that.
Okay, so you wouldn't use cookbook file here. Later we're gonna talk about templates, and we'll switch this to a template, and then I'll explain why you wouldn't use cookbook file here. Yes.
I made sure the directory existed.
You made sure the directory existed. How did you do that?
The directory.
Oh, you did a directory resource. So like down here, you did directory
No, but,
above. Why did you do it above?
because otherwise the file resource won't there.
So you did something like this. Is that all you did? How else did you just find the directory?
I did recursive true.
You did recursive. True. I like that.
Yeah.
Yeah,
Just save on the file.
good. But you put it above the file. Why did you put the directory above the file? Does that matter?
I believe so.
I believe you're right. Yes, so it was totally a trick question. Order matters with Chef, except when it doesn't, but usually it does. So, and I'll explain what I mean, because that sounds just ridiculous, like you'll never understand how this thing works. So with this directory resource, so to be clear, you don't need to have this, because when you installed Apache, it created that directory for you. But as I said earlier, if you want to be more intention revealing, you could totally create a resource that is that directory that will ensure that that directory exists. So the problem with my code as it stands, let's say that the directory var www.html did not exist. When Chef encountered this, we tried to put a file called index.html into that directory. If that directory doesn't exist, that resource would fail. And what would happen is Chef would stop there. It would throw an error. You'd see a stack trace that says, I can't put a file in a directory that doesn't exist. So order matters. If we want to declare the directory, we should put that directory above the file. We do that. And when I said order matters, except when it doesn't, so it always matters, except in this case. Between the do and the end, like this could be mode and then content, or it could be content and then mode. That order doesn't matter. The order of the attributes and the actions that you specify between do and end doesn't matter. The order in which you list your resources are the order in which those resources will be applied to the system. So I'm going to save that. You may have other changes that are different, but I think we kind of get the idea. So I'm going to sudo chef apply apache.rb.
So I have a question.
Yes.
When when something doesn't work, chef actually stops and fails,
Yes,
right?
that's correct.
Because I've had a little experience with salt,
Uh-huh.
and that's a bit different. When you,
Yes.
when a resource or the equivalent fails,
Yep.
then the other resources are still applied, or there is an attempt to apply them.
Right.
And sometimes you get really weird extra codes, like you can fail on an installation and still get a 0 extra code.
Yeah, that's weird.
So it's always a behavior with
With Chef, the behavior is always, if a resource fails, stop executing the Chef client, or in this case, Chef apply, throw a stack trace, and error out. There is a way to prevent that though. So for better or worse, Chef is basically completely customizable. So what you could do, there's an attribute for every resource called ignore_failure. You could set that to true, and then if that resource failed, Chef would continue processing on.
I swear it's not personal, but there's something happening and I have trust in you.
It's totally good. I will not hold it against you at all. Thank you. See, like what you need to do at in a class like this is have your mates text you and be like, "Oh my God, I'm on call. I gotta go deal with this, right?" Like it's that date. There's a dating app I think that will do that. Like an hour into your date, it will send you a text, and so like it's an hour in, and now you got a text. Uh-oh, the site is down. I have to go fix it. Sorry. Did I answer your question?
yes, you did. Thank you very much.
You bet. Yes.
Two-part question.
Sure.
Is there a way to get Chef to create the directory for you, as opposed to just failing if the directory doesn't exist? And the second is, what if it errors out? Does it roll back to a previous state, or just?
Sure. Two great questions. So if what fails is that there's no directory, Chef should be smart enough to figure out, you said put a file in this directory doesn't exist, just make the directory for me. No, the way that you make Chef make that directory for you is you declare the directory resource. And here's why. I'm gonna give you asked me a two-part question, I'm gonna give you a two-part answer for here's why. The first part is, because that's the way it works. The second part is, because Chef can't make an assumption about what are the attributes for that directory that you want, right? Who should own that directory? You don't want Chef just guessing at that for you, right? So it won't create that directory for you by default. You have to declare that directory if you want that directory there. The second part of your question was, I don't remember now because I talked.
If it fails in the middle of something and you have more instructions, what would it do? Would it roll back to?
Oh, would it roll back? Would it roll back? Yes. So this is Surge. I feel very confident in saying this. Rollbacks are a lie. There is no such thing as a rollback. It is only roll forward ever. So Chef is not like, there is no transaction that happens when you apply the Chef client. It's not going to say, oh, I applied 3 resources, the 4th one failed, so I'm going to undo the things from those first 3 resources. No, it leaves the system in that state. Yeah. Awesome. Okay, so it is now 11:12. So what I'd like to do is propose that we break for lunch around 12:30-ish. Does that work for everybody? Because we didn't start till 10. I feel like noon is a little early to break. But what we should do is let's take 10 minutes here. And by 10 minutes, I mean 8 minutes, just so that it's like 11:20. No, we can come back at 11:22. Oh, it's 11:13 now. 11:23, I'm going to start talking again. And what I'm going to start talking about is I'm going to ask you, do you want a demo or do you want to learn more? And I'm going to write down a list of things that Travis, who's not here, so a list of things that Adam or I can demo for you. So you'll see that list and we'll ask that same question, learn more or watch a demo? We'll ask that same question like 2 or 3 times throughout the day. Fair? You have until 11:23 and then I'm going to ask that question. If you don't care about the answer, you can take until 11:25. Good? Those of you watching the live stream, we're going to be like dead air for about 5 minutes here. And thanks for tuning in. That was a funny joke, and the internet didn't get to hear it. Okay, so we're back. Let's see. So Chef Delivery. So Chef is awesome at configuration management, right? Describe your desired state, manage your infrastructure from provisioning to deploying applications to keeping things running and in that desired state. But what about your applications that you want to, or your infrastructure changes that you want to deploy? So there's this idea of continuous delivery. Chef Delivery is a product that enables continuous delivery for both your application code and your infrastructure code. So it's different than any other continuous delivery tool you've used. And so we have this thing, and we can demo what that is for you.
Is that like the difference between client server mode versus running from the host itself like we're doing now?
So I would say no. The big, like, it's sort of just different. So yes.
Pipeline?
Yes.
You demo Chef Delivery?
It's super pipeline-y, yes. All right, so you want to see delivery?
Yes.
Okay, delivery is the thing that will take us until lunchtime if we demo this. But is that cool with everybody? Because I love to demo some delivery. It sounds like people are interested in this. Yeah? All right, awesome. Oh, this could be really fun. So the other thing, the other thing that I'm just realizing now about delivery is I totally have a demo environment, and what I haven't done in about 4 weeks is tested that demo environment. So what could totally happen is it would fail as we watch it, which would be awesome, right? Because then you could watch me troubleshoot. It wouldn't be awesome for me. It would be awkward, but yeah, we'll see how that goes. I would love the lunch break to like make sure that it works, but it's cool. It's cool. I will give you what you want. It's always better to just do it live and let's see what happens. Also good to couch, like when it breaks, it's not my fault. I mean, of course it's my fault, but yeah. So it might break. But here we go, Chef Delivery. Chef Delivery, what is Chef Delivery? So people that we work with, people in this room, people all over the web are moving to a place where they want to do continuous delivery. How many of you feel like today you're doing continuous delivery with your applications or your infrastructure? Awesome. That's good stuff. So a bunch of our customers are doing the same thing. And Chef has worked with people for a long, long time on how to manage their infrastructure. We work in this DevOps space and talk to people about that. Most of the time people want to do DevOps, or oftentimes people want to do DevOps to be better at IT, to create high velocity organizations. And usually that means heading towards continuous delivery, wherein when I make a change, it can continuously, my changes can continuously be delivered to my production environment. So what we've done is we've worked with a bunch of customers, both large customers and small customers, internet startups to big banks, and figured out like, what does a pipeline look like? What's the shape of a pipeline? And what we've done is we've taken the practices of these various customers and we've productized them, built a product called Chef Delivery around those practices. So we have this pipeline that we've validated, it works really well, and that's what Chef Delivery is, yes.
Can you give a two-sentence explanation of the difference between continuous integration and continuous delivery?
I certainly can. So continuous integration means this. You are continuously integrating your code into your master or trunk or mainline branch. That's continuous integration, period. Like that's the end of it. Continuous delivery means that once it's in master, what's going to happen next is it's going to be delivered to your production environment. Is that clear? Good? Okay. And anyone want to argue with it? I mean, it doesn't matter if you want to argue. Yes?
Well, I mean, inherent, these days, you're always compiling, unit testing, what are the main line, and ideally,
yes,
all those sub-branches is the ideal. But
yes, so there's this thing with continuous integration. Sometimes people, and when I say sometimes people, what I really mean is in the past, I used to think this way. So sometimes people think this way. In the past, I used to think this way. If I'm running, if I cut a branch in my Git repository, and I run my tests against that branch, if I run my test suites against that branch, and I run my test suite against all of the branches that I ever cut, I'm doing continuous integration. Because I'm executing my tests on all of my branches.
I used to think that. That's a lie. So continuous integration doesn't mean that. What continuous integration means is that you're actually integrating those branches back into master and running your tests there. That's the thing that really matters. And when you get to this, and one of the sort of behaviors that delivery enforces or helps you adopt is that you don't have long-running branches. All of your branches, all of your feature branches are very short-lived, and what you're doing is continuously integrating those branches back into master. Okay. Awesome. So here's what the Chef delivery pipeline looks like. You create a new change. I don't care what the change is, if it's application that's changing, your infrastructure, like your Chef recipes that are changing, it doesn't matter. So you create a new change, and then you test that change locally. You're gonna run your unit tests on that change, your syntax tests, linting, so forth. You run all of that. When you're happy with it locally, you will then submit that change to be delivered out to your production environment or to your delivered environment. When you submit the change, verification tests will automatically run on that within your pipeline. And then someone will come along and review that change and approve the change. So one of the rules that we have within Chef delivery is what we call the 4I rule. And the 4I rule states this: no code makes it into your delivered environment without at least 4 eyes looking at it. Now, for better or worse, those people like me that wear glasses, that doesn't count as 4 eyes. However, I will tell you that my code is always production ready, so it's cool. Like I can review my own code, it's fine. So once that code has been reviewed, that code then gets approved. Once it's approved, you will build artifacts from that code. Those artifacts might be cookbooks, they might be a jar file or a WAR file or an RPM or whatever sort of artifacts you build. You'll then run acceptance tests against that built artifact to make sure that it's good. And then when that's done, the change will be ready for delivery. It will be ready to go into your delivered environment or your production environment. And someone will come along and deliver the change. So you essentially have push button deployments of all of your changes and testing all through the pipeline. This is the high level overview of how delivery works. You create a change, you test it locally, you submit it for review, it gets reviewed and approved, it then gets delivered. What questions can I answer for you so far?
All of these pipeline is managed in the Chef server, or?
Yes, it's managed in Chef delivery, which is like a separate component from the Chef server itself. Yeah.
Sorry.
Yeah.
My question is, the Chef delivery, does that come with the enterprise license for the Chef?
Okay, so the question was, does Chef delivery come with the enterprise license for Chef? So first, I don't know why I do this, and also I apologize for doing it, and then I do it anyhow all the time. I'm gonna be pedantic again. So you may have purchased an enterprise license from Chef. We don't sell enterprise licenses anymore, and I'll just describe what I mean by that. It's really just words. So you can kind of say, man, dude is an ass. I wish you would just answer my question. It's cool, you can say that, I'll take it. So Chef server is open source, period. When you use Chef, you're using open source Chef. You can purchase premium features on top of Chef. So delivery is a premium feature that comes on top of Chef. So that's the first part of your question. So it does not come with your enterprise license because we don't sell enterprise licenses anymore. We sell premium features. But like you're like, I really don't give a fuck. Can I like, how do I buy this thing, right? And then delivery is sold separately from the core premium features. It's like an add-on to the add-ons, if you will, right? So yeah, all right. Like I could have just said, I don't know, no or yes, and you would have been fine. I could have said yes, and you would have been like, great. Instead, I take 5. This is why this is going to take until lunch. Right? I won't shut up. You had a question also.
Yes, I'm sure you're going to show us, but would this tool be comparable with something like GoCD?
Would it be comparable to something like GoCD? So what I will say is yes, and I'm gonna say yes.
Right.
How about that? Yeah, I'm proud of myself. I didn't keep talking. That was pretty good until I congratulated myself for not talking further. So here's one of the key things about delivery, though. With delivery, we have a common pipeline. So all of your code is going to flow through this exact same pipeline. And what that means, and we're going to look at this, like I'm not just going to show you slides, we're going to move a thing through the pipeline, and if we're lucky, we'll move 2 things through the pipeline so you can see fully how it works. So each one of our applications, whether they're applications or cookbooks like infrastructure code, each one will have its own acceptance pipeline. But then after it gets through the acceptance phase, it's going to move into a shared delivery pipeline. And that's, this is super important, and I could talk about it for 20 minutes, or I could show you in code. So let's walk through some code, shall we? All right, now it gets fun. We get to, let's see what I can do here. I think I want to go here. Nope, that's not it. Yeah, there we go. All right, that looks good. That so far so good. I'm sure that's fine. Just get this demo environment set up here. You'd think like, I don't need to go there. That's not. Oh, that's my lab from before lunch or before our break, totally working. That's not what we're here to see though. Oh, yeah, that's good. All right, I don't think, I might need that, I don't know. At least the network is good. Okay, so let's see, what else do I want to, there's something else I need to do here. Marine. All right, so let me talk through this environment that I have set up here. So if we look back at this slide, not this slide, but this slide here, I'm gonna bounce back and forth between the slides and the code. So we have 3 different environments in our delivery pipeline, one that's called Union, one that's called Rehearsal, one that's called Delivered. I have open in my browser 3 different tabs. One that's called Delivered. You can't see it probably, but up there in the tab it says Delivered. Maybe in the back of the room you can kind of tell that that is different than over here where it says Rehearsal and over here where it says Union. So what I have right now is a web application, and by web application what I mean is static website deployed to my Union environment, my Rehearsal environment, and my Delivered environment. And when I'm switching tabs, you can't tell the difference because they're all the same, which is exactly what I expect. Now, additionally, I have, much like what I gave you earlier today, I have a delivery workstation that's up in the cloud, and it has 2 cookbooks associated with it. One that's called HTTP and one that's called site. And you'll argue with me that those are not the names of the files that I just pointed at, and you're right, it's not, but I'm just gonna call them HTTP and site. The DBAAS, the DBAS, we're gonna just ignore that bit for now. In the site cookbook, there's a recipe. Let's just look at that recipe. Now, bear with me, because we haven't finished your fundamentals, like your intro yet. So this is a more advanced chef recipe, but I think, because I taught you about resources, I think you should be able to follow basically what this code says. You should at least be able to read the code without too many problems. So first thing it does is it includes a recipe. We didn't look at including recipes, but a recipe can include another recipe. Here it's calling a recipe from the other cookbook, from the HTTP cookbook. There's a recipe called install HTTP. So it's going to basically inline that recipe in this one. And it's going to set up a template. Oh, and as you might guess, the install HTTP recipe is going to install HTTP for us, much like we just did in install Apache. And then it's going to write out a template at etc apache2 httpd comp. So it's going to write out a configuration file. It's going to use a remote file resource. We didn't look at remote file, but I bet you can figure out what's happening here. So the first thing we do is create a little tarball variable. So this is just Ruby, create a thing called tarball. And then we're going to grab this thing remote file. We're going to store it at this location in the file cache map at webfilestar.gz. It's a remote file, so we're going to give it a source. So when Chef sees this, what it's going to do is test and repair. Is there a file at this path, webfilestar.gz? If there's not a file, go out to this source URL, go to this S3 bucket, and download that file. Put it in that location. And there's a template file, var HTML index.html. Looks very similar to what we did with our file resource, but this time it's a template. We're going to look at that template in a second. And then it's going to run an execute, extract the web file. So it's going to unzip that tarball that we just downloaded. But it's only going to do that, it's not going to do that if the fave icon exists. So this is just a way to know that it's already been extracted. You have a question?
For the remote file, does it do any checking to make like the integrity checking to make sure it's an actual valid file?
So we could, in this resource, we could specify a checksum, and then it would make sure that the checksum is correct.
But otherwise, it just checks to see if there's a file.
Otherwise, it's just going to make sure, like, if that URL is bad, Chef's going to bomb there. But otherwise, it's going to download the file that you told it to do. It's kind of stupid, right? It only does what you tell it to do. Fucking computers. I mean, it's ridiculous. Okay. Any questions about like what this recipe does? Pretty straightforward. Yes.
At the bottom is your fake icon check set in the right direction.
That's a good question. Yeah, it probably should be in the HTML. I don't know. It maybe extracts these web files every single time. Like, it seems like this bad recipe maybe. Maybe a good thing to fix. We're not going to fix it today, though. But what we are going to do is we're going to look at this source index.html.erb. So I'm going to just open that up. It's a template. Templates. Default index.html.erb. And then there's a couple of things that we're going to look at here. So first, we have this line here. It would be better if it were higher on the screen for you to see. There we go. We have this line here, node.chef_environment. So that's the title bar for my page. So if I go back here, see where it says union, you can't see it. You trust me, where it says union here, it says rehearsal here, and it says delivered here. That's all the title. So that's the environment for that thing. So that's dynamically generated. But then the other thing that's interesting is not the project name, it's the company name. I mean, they're both interesting, but it says in the header, hello, node site dbas company name. And if I look at that index.html page, it says hello, chef friends, right? So that is an attribute that's stored as part of my cookbook. So if I look at the attributes for this cookbook, you'll see there's one called company name and one called project name. The project name says I am flavor text, paying me no mind. And if we look back on the website, we'll see that that text exists. and then we see the company name is Chef Friends. So what we're going to do is we're going to change that company name from Chef Friends to something else. We're going to change it to Surge. So back to, like, what are we doing? Where are we in the pipeline? In our pipeline, the first thing that we do is we create a new change. So I've just changed the code of this cookbook. I've created a new change. I'm not completely done though with the changes that I want to make, because if I do a git status, so we'll see I'm in a git repository, I've changed attributes.rb. I'm going to go into the cookbook's metadata file. So a recipe lives within a cookbook. A cookbook is the thing that you distribute as an artifact. You can think of it like a Ruby gem or an RPM or something like this, a tar or a jar. Each cookbook is going to have a version number. It's not going to have a version. It's going to have a version. Got it? Everybody stayed with me there? Yeah, okay. Some of you are still awake. That's good. So it has a version number, and I'm going to change that version number because I changed the code. I'm going to change it from 0.1.0. I'm going to change it to 0.1.1. The other thing I'm going to do is we want short-lived branches. So I'm going to git checkout -b. We're going to call this Nathan Surge. Now I have two files that have changed. I've changed the attribute. I've changed my metadata. And I'm on a new branch. So back here, I've created a new change. The next step for me to do is to test that change locally. So I'm going to do that before I submit my change. One of the things that we can do to test this change is we can run a syntax checker on it, like a lint test. Within the Chef ecosystem, there's a syntax checker called Food Critic, because what else would you call a syntax checker for Chef? So I'm going to run Food Critic on this thing, and I don't know how to spell Food Critic. This is the part where you laugh at me and point. The other thing, and it passes, so there's no failures there. It would be better if it showed a failure, but it didn't. There's another tool that we use or can use called Rubocop. I can run Rubocop on this directory. That has at least more interesting output. It inspected all the files, no offenses detected. This change feels pretty good. I should probably run my unit test, but for the sake of time, yeah, unit test is probably fine. So what I'm now ready to do, I've created a new change. I've tested that change locally. I'm ready to submit that change. Before I submit that change, I want to check in on how this network is doing. Ah, great, perfect. Let's see, should I look at that? So here's another great thing. Sorry, before I submit that change, I want to talk about this web view here, this browser that I have open. This is delivery, Chef Delivery here. So a couple of things about delivery. The first thing is delivery gives you a standard pipeline for all of your applications and infrastructure code to go through. The second thing is it encourages you to work in a way that is successful for continuous delivery. The other thing that it does is it allows you to easily visualize change as it moves through your infrastructure or through your organization. I'm just going to make that a little bit bigger. Yes?
Can you use it with non-Chefy things?
Can you use delivery with non-Chefy things? Yes, you certainly can. Yes. I love yes/no questions. Although I find them difficult to give you a one-word answer, apparently. Right. So we can see there are no current pending changes, or maybe there is, but we're going to add another one. Anyhow, that's the other cookbook, so it doesn't matter. Okay, so we've tested the change locally. We're now ready to submit the change. So we have this branch. It has a couple of changes on it. Let's go ahead and get status. You forgot to point and laugh. So I'm going to commit these changes here. Git commit. Thanks again. You guys are awesome. You're really helping me not look stupid. I appreciate it. Cool. All right, so I've committed some changes here. Git status shows me that I'm clean. And of course, there are differences between my branch and master now. So what I'm ready to do though is delivery review. So I want to submit this change for review. So part of Chef Delivery includes a delivery command line interface, a CLI, and that includes this command called delivery. So I'm going to type in delivery review, and then I'm passing this flag called no open, and I'll show you what no open means. So if I were running this on my local workstation for my Mac here, what would happen if I ran just delivery review without -- no open? Then my browser would open up to this URL. But since I'm SSH into a workstation and I don't have like X11 Windows running or anything like none of that, so I don't want to open up a browser on that machine that I can't access from here. So I'm going to just take this URL and I'm going to go there. But of course, the other thing I could do, if I look back at my dashboard, so I copied that URL, I'm not actually going to use it. But if I look back at my dashboard, we can see site has now shown up here. There's a change sitting in the verify stage for my site cookbook. So I can drill into that and say, hey, look, there's this change called welcome to Surge. And what happens when I submit a change is I'll make that bigger. When I submit a change, the system is automatically going to verify that change. And by verify, what I mean is it's going to run a lint test, it's going to run a syntax check, and it's going to run a unit test against that change. So it's going to run all of those changes for me. So if we go back over here to the browser, what we can see is that it's actually made it through all of those. So let's just drill in and see what happened here. So when it verified, it ran unit tests, lint tests, and syntax tests, and all of those passed. I could drill in to see like what's the output of each one of those, how did they do, what did they do, and so forth. So the the lint test runs Food Critic and Rubocop, like I just did locally. The syntax check uses Knife Cookbook test. It makes it harder to see when I highlight things, sorry. It runs Knife Cookbook test on all of those things. So now what's happening, this change has been automatically verified.
Those steps are
yes.
customizable.
So here's the thing. When we get to verify, the stages in verify are always lint, syntax, and unit. The definition of lint, syntax, and unit is completely customizable, right? So what we do is we give you a default definition for each one of those stages if what you're doing is managing cookbooks. If what you're doing is managing Java apps, we don't have yet a default definition for what does it mean to lint, syntax, and unit test your Java app, but I'll show you how you write those. Okay, so I'm ready to review the change and then I'll approve it. So let me go through the review stage. So to review the change, it's important to remember the 4i rule. 4 eyes have to look at this code. So I can hit start review. I can come in and I can actually see the diff in my browser. Any of you used Garrett before? Yeah. Does this look a little prettier than Garrett? Just a little, maybe? Because that's what we were going for. It should be a little bit prettier than Garrett. Well, maybe we're going for a little bit more than that. But so I can look at the changes here. So I changed Chef Friends to Surge. I can look at the next file. I can see that the version changed. I can make comments here. So I can come in here and say, oh yeah, Surge is the best. And somewhere down here, if I make my thing smaller, there must be a way to submit that thing. There it is, add comment. Push the add comment button. There we go. So Surge is the best, and a little thumbs up because that's awesome. So that's fun. And then I can come back here to the review. over to my status, start review. All looks good. I can add comments here, like ship it. The comment, we got a little ship it squirrel happening. And now I can approve it. But before I push the button, can I get just a head nod? It's okay to approve this change from somebody. All right, great. There, I did my due diligence. I got 4 eyes to look at that, at least 4 eyes to look at that code change. So are you sure you want to approve this change? After approval, this change will be merged to master. Continuous integration means that we merge our changes to master all the time, short-lived branches. So the minute I hit confirm on this, that's exactly what's going to happen. These changes can be merged into my master branch. So I confirm that. And now it's going through the build phase. So back over here, if I look at the our flow, I got ahead of myself there. So the build phase does this. It merges your code back into your master branch. It then runs your lint, syntax, and unit tests again for you. We just ran those in the verify stage, but something else may have come along into master in the meantime, so we want to run them again after it's been merged in. After running those, we then run quality and security tests. Assuming that all of these pass, we will then publish. We'll run the publish recipe. And for our purposes, what publish is going to do is take this cookbook and publish it to our Chef server. So let's go back over here. And by over here, I mean back to my workstation that I'm logged into. If I git checkout master and do a git pull here, see that it just pulled in those changes. So these changes have been merged into master. I can run a git log and see like what's happened here. I can make that a little smaller so it's actually legible, maybe. To my even computer. Let me I'll just run that again. You can see that the delivery server merged in this change, that it was approved, was signed off and approved by the same person, and it was reviewed and signed off by the admin. I'm the one that submitted it, and so forth. So back over here in the delivery phase, or in the delivery UI, what we can see is that the unit, the link, and the syntax have all passed. The quality and the other one, I don't remember what the other one was. Security, yes, I think those were skipped. So it's always good to write tests that you just skip. So to show you how easy that is, we skip a couple of those phases. So we skip past those, and then we did the publish phase. And so it's now taken that cookbook and published it up to my Chef server. So after doing the publish phase, the next step is it's going to run the acceptance. And what's going to happen in the acceptance is this. It's going to provision an acceptance environment. So an acceptance environment is, well, it's however you define it. For me, an acceptance environment is a web server that runs my built artifact. So my built artifact in this case is that cookbook. So it's going to grab the latest version of that cookbook from the Chef server. It's going to execute that thing and make sure that it works. So the first thing it does here in the acceptance phase is it does a provision step. What provision will do is create an acceptance environment for me, unless one already exists. And the way that I run this delivery pipeline, the acceptance environment already exists. If I look over here in a browser, I have this environment here. At the top, it says acceptance. If I refresh this page, it now says hello Surge. So what delivery did was it said, go create a site or an app, a node called siteacceptance.dbas, or whatever it is that it's supposed to be called. It saw that that thing was already there, so the provision phase was done. It then said, deploy this new cookbook there. So it ran Chef Client, pulling down that new cookbook. And then it ran 3 tests for me: smoke test, functional test, and compliance test. And probably what happens in these 3 tests, we probably skip some of them right now. And then we probably hit the local host and make sure we get a 200 response back. To be fair, that's probably all the testing that we've built into this little demo here. So let's check it out though in the delivery server. we can see that it's gone through provision, deploy, smoke we skipped, functional, passed. It's now ready to be delivered. So this is the magic moment. We've made it through all of these changes. We're ready to deliver that change. When we deliver that change is going to be deployed to our union environment. So remember, we have 3 different environments: union, rehearsal, and delivered. Union, if we go back, let's go back a couple of slides here and look at this slide here. So each project that we run is going to have its own acceptance pipeline. So this change has made it through our acceptance pipeline. It's now ready to be delivered. So when I click the deliver button, it's going to take this change and put it into my union environment. Here's the thing about my union environment. My union environment is everything for that step, for that application. Remember, the first thing that happened in our site recipe was we included a recipe from another cookbook. You remember that? We included the install HTTP recipe. Well, this change is dependent on that other cookbook. Before I put it into production, I want to run this change with the current version of that other cookbook. I'm going to bring them together in my union environment to execute those. So I'm going to come over here and I'm going to push the deliver button. Let's deliver this change. Are you sure? This is the following change will be shipped to union. And I'm sure, so I'm going to confirm it. And so now what we can do is we can watch in delivery. We can see this change move through union, rehearsal, and delivered. And I want to just walk back through our pipeline to see what's going to happen here. So here's what's going to happen in each one of those environments. First step, provision that environment. If union doesn't exist, create it. Union already exists for me. Deploy that new cookbook. So it's going to grab the latest version, the 0.1.1 version of that cookbook, and execute that there. Then run my smoke, functional, and compliance tests. So if I come over here back to my browser, let's see if we can catch it. In Union, it says Chef Friend. If I refresh the page, it still says Chef Friend, which doesn't mean it's broken. It just means that it's running. Deploy just finished. So now if I refresh this page in Union, we see Hello Surge. As soon as Union is done and passes, it's going to go to rehearsal. So if I refresh this page, it's still going to say Chef Friends because we haven't finished Union yet. It's running my functional tests in Union. Union is done. It passed. It now moves on to rehearsal. And it's going to do the same thing in rehearsal that it did in Union. So it's going to provision a rehearsal environment. It already exists. Run that new cookbook. Do the deploy. It's going to deploy that cookbook. It's going to run our smoke test, our functional test, and our compliance test. And then when all of that passes, the last step is it's going to do the same thing in my delivered environment. I want to pause here and ask what questions can I answer for you. Yes?
Why the rehearsal?
That's a great question. I'm going to come back to it. I'm going to come back to it. It's just going to take me a second. I'll get right back to it. What else? Yes?
I mean, are you defining compliance? Is there a structure for the test? So there's smoke, functional, and compliance? And
yes.
Compliance is not a common term that I've learned.
Right. Yes, so compliance test is going to be like an audit. So if you think about maybe you have to be PCI compliant. You can write with Chef Audit Mode, which we haven't really talked about at all, except it's on our list of things we can demo. You can write checks. You can write basically controls that enforce or verify that you are in compliance with whatever regulatory things you have to follow, right? So if PCI is a thing, what we can do all the way back in our acceptance environment is make sure that the change we made didn't break our PCI compliance in this environment. So we'll run all of our controls there. So instead of waiting until we've deployed to production and then running a scan to figure out are we still compliant, let's catch that in the build phase instead of waiting until the end. Yes?
Is this also the same in the cookbook or your app?
Yes.
at this level, right, without looking at the details, this is the delivery pipeline. It doesn't matter if it's infrastructure code, like Chef cookbooks, or application code, like a Java thing, or a Rails application, or whatever. This is the process that it follows. The place where it gets different is in these little green boxes, or turquoise, whatever. I'm gonna call them green, I hope that's okay. The way that you deploy a cookbook is going to be different than the way that you deploy a Rails application. So that's where you're going to customize the way this pipeline works. But this is the shape of the pipeline, and this is always the shape of the pipeline. And it doesn't matter if it's infrastructure or applications. And the reason that we do this, those of you that said you're doing continuous delivery earlier, how many of you are doing continuous delivery for more than one thing in your environment? And of those, how many of your pipelines are identical across those things? Right. Like everyone builds a bespoke pipeline for every application that they deploy, whether it's infrastructure code or application code. But what we find is that when you follow the same pattern, we all now have this language that we can use to describe the pipeline. And when we say that this change is currently in acceptance or waiting to be delivered, or is in the union environment and that's where it failed, we can say that about all of our applications, all of our infrastructure, and everyone on the team can understand what that means because we have this common understanding of the pipeline. Now, let me just show you a couple of things, then I'm gonna get back to your question of like, what's up? Why do we need this rehearsal environment? So each project that you want to run through your delivery pipeline is going to have a build cookbook. So your project itself is the project code plus the build cookbook. The build cookbook is where you define what does it mean to do lint testing? What does it mean to do syntax, quality, security? What does it mean to publish a cookbook? So there's code, that code might look like this. If I'm in the unit test for a Java application, we're not gonna run chef spec on my Java application. That doesn't make any sense. We're going to run Maven test. So here, it's just a recipe. So you essentially define in a recipe, what does it mean to do unit tests? What does it mean to do lint tests? What does it mean to do syntax tests? And then in the deploy phase, we have to think about what does delivery support? So if what you're deploying is a cookbook, what does it mean to deliver a cookbook? Delivering a cookbook might mean that you want to publish that cookbook to the supermarket. The supermarket, by the way, is a place on the internet where anyone can go and share cookbooks that you've written. So you can go and grab other people's cookbooks and use them in your environment, or you can publish and share them. It's kind of like Ruby gems. You can share gems there. You could also stand up an internal supermarket, much like you can an internal like gem host. And so that publish to the supermarket might be you publish to your own internal supermarket. It could be that you publish to a chef server, or it could be that what you're doing when you deploy a cookbook is you're delivering a change to your infrastructure. So you update all of the nodes within your infrastructure. In our particular case, what we're doing when we deploy in this example, when we deploy a cookbook, we're putting that cookbook on the chef server, and then we're telling the nodes in our infrastructure to run chef client, so to update with the latest version of that cookbook. It could also be that what you're doing is using Chef Delivery to deploy your applications. Well, if it's a Rails application or a Java application, you're not going to deploy it to the supermarket. You're not going to deploy it to the Chef server. You're going to deploy it off to the nodes in your infrastructure. What I don't know is what does it mean for you to deploy your application? But what I can tell you is you have a deploy.rb, a deploy recipe, in which you will define that logic. Yes?
So you either deploying to the Chef server if your nodes have Chef clients, and then they get, that's kind of the same thing as deploying it to the individual nodes.
Yes. Yep.
Okay, but let's come back. Oh, now it's time to demo. Sorry, I did this thing all out of order. It's a thing. Let's come back to your question though around what happens. Why do we have? I should talk about the inner monologue so that you know what I'm thinking.
So I did that. So why rehearsal, right? So is it clear why we have a union? We want to bring everything together that's going to make up this stack, right? When you manage your Rails application, you probably have a repository that is your Rails application and a separate repository that is your infrastructure, like your Chef cookbooks. But also microservices, that's where it's at. When you manage an application, what you really have is 100 different repos that make up all of the microservices that make up your application. Well, I want to test all of those microservices or all of those components together. So I bring them all together in the union environment. And in my union environment, I have the whatever change was just delivered, plus the current versions of everything else, every other component. Well, let's just think about this for a second. If union breaks, so it fails, what I need to do then is make a change, get it through acceptance, and apply that change to my union environment. And then union's green, and then things can move on, right? But here's why we have the rehearsal environment. What if, and you're gonna have to stick with me for a minute, all I have to describe this are words, they don't have slides or pictures, so you're gonna have to stick with me. What if union breaks, and the way you fix union makes an assumption that it's broken the way that it's broken. And the fix only works because it was in a previously bad state. When you apply this change, it brings it into a good state. Does that make sense? So it was busted, I made a change, that fixed it, but it fixed it because of the way it was busted before. Rehearsal is never busted that way. So now I'm gonna take all of these changes and apply them to my rehearsal environment. If it applies cleanly there, I have confidence that I can move it to my delivered environment. If it fails there, now union is in this other state that is green, but rehearsal failed. So I need to figure out why did rehearsal fail, make whatever change is required back in my acceptance pipeline, and get that delivered. It will deliver to union, it should apply cleanly, deliver to rehearsal, where it should then fix that problem, and now I have more confidence that I can move it into my delivered environment. Does this mean you'll never introduce a bug in your delivered environment? No. Does this mean you're less likely to if we went straight from union to delivered? Absolutely. All right, I saw 3 hands. That one was first. Go.
All right, my question is, so the union environment is saving its current state all the time?
It depends. So in my particular demo that we've just walked through, the union environment is a static environment that we sort of converge on a regular basis. But part of your deploy process could be after I deploy to union and my functional tests have run, like the last step in my functional test could say destroy this environment. Because the first step in union is to provision. So with each one of these, like with every change, this infrastructure could be fully disposable. You kind of have 2 choices. You either have disposable infrastructure here, or you have convergent infrastructure here. Convergent meaning it sticks around until the next change comes along and then we apply that next change. There was one up here. Yes.
Yeah. If rehearsal fails,
yes,
then that's in a bad state.
Yes.
And so when it goes through again,
yes,
isn't rehearsal then acting as union?
In a way. It's in a way like
how do you get rehearsal back to production?
How do you get rehearsal back to
production base
to match what delivered is? I don't know. I don't know. What I could do is make up some bullshit, but I won't do that. I'll say, I don't know. Cool. What other questions can't I answer for you?
Well, I mean, it makes total sense to me that what you really want in rehearsal is whatever's delivered.
What you want in rehearsal is what's in delivered until you have the next change coming through.
Right. So when I'm about to deliver something into rehearsal, I want rehearsal to be exactly the same as delivered, so that I can break it the same way that I break it.
So when you have convergent infrastructure for these 3, that becomes more difficult. When you have ephemeral or disposable infrastructure for these 3, that becomes a less trivial thing to do. Right? Yes.
So the union environment could be provisioned with every change, and then rehearsal could be a constant environment.
Yes. Yes. So union could be, I provision like it's brand new with every change. Rehearsal could be a thing that's surrounded and is convergent. What you really need to think about though is, what's your delivered environment? What is that for you? Is that something that's convergent? Or is that something where you're doing like a green-blue deploy, where here's a change and I deploy it to this environment, my load balancer is pointing to this one, DNS is pointing to this one, I've validated it over here, now I have to update DNS and point over here. So the pipeline is the same. What I can't answer for you is like the full details of how you're going to deploy your apps.
Right, gotcha. The reason I asked is because we run into issues with our Chef where we have machines that exist already. We'll make a change to a QuickBook, and when it goes out, because we only tested when we provision new and there was already an existing state.
Yes.
It breaks in the existing state.
Yes.
New deployments work, or vice versa.
Yes.
New deployments don't, but delivery are already existing environments work.
Yes.
So in this,
That's maddening.
An opportunity to test.
Yep, you could totally test both ways, and that's super maddening when it does that, isn't it? Chef is terrible. Fails when you provision new, works when you converge, or vice versa. But of course, it's not Chef, it's you. I love you. Yes, yeah, so you could model that there. Were you gonna ask something? No, okay, and you have your hand raised.
So in our environment, we actually go to a canary environment.
Yes.
So that, I guess I was originally thinking it was rehearsal, but it sounds like it's actually delivered.
Yes.
Canary, and then when we go full, we
yes.
deliver +1.
Yes. So it starts to get tricky when we get into these sorts of details. But here's the thing. Delivered is the final stage of your delivery pipeline. These are the things that you need to consider as you think about this. Delivered is the final stage. When it reaches the end of acceptance and you click deliver, if all goes well, it's automatically going to move all the way through to delivery. You do not have a chance to add a human gate here or add a human gate here. These do not exist. If it passes here, it goes to here, it goes to there. Likely, what you want is to continue to say, all right, this is my canary environment, right? But how do you tell your systems to go, all right, canary is good, now I want to deploy it everywhere? And the short answer is, if the way that you do that is with code, then that code is another change that comes along. That change maybe isn't actually going to change anything in Union. It might not change anything in rehearsal, but it may change your delivered environment. I can tell by the look on your face that you're not quite sure how that's going to work. And what I will tell you is, neither am I. But if we sat down and worked through this, I'm confident that we can get to the right answer. Yes.
How scalable are Union and rehearsal as far as servers go? If we have a long-running cookbook that's being tested on Union, can we have another server in there that tests other stuff?
Sure. So the short answer is the first stage of each one of those is provision. So Union is not a server. Union is the cluster of servers that you provisioned, right? And so then the same is true for all of those environments.
But it sits in a Chef environment.
Exactly. So if you're familiar with Chef and know what a Chef capital E environment is in Chef, this is a Chef environment. This is a Chef environment. This is a Chef environment. So it really implies that you have a cluster of nodes that sit here, a cluster that sits here, and a cluster that sits here. For my very simple demo, what we have is a static HTML site, right? I don't need a cluster of nodes for that. Okay. I think I have to click a bunch of times to get to the end of this deck. I just want to make sure that I've talked about everything that I wanted to talk about here. Oh yeah, because I got to the demonstration slide, which is what you do at the end, always. Okay, so it's 12:20. I'm gonna give you 10 extra minutes for lunch, because I said we'd break at 12:30. So let's break from now until, should we say 1:30?
Does that maybe work for everyone? Here's the thing, if it doesn't work and if like the restaurant took too long and you're not back at 1:30, then I'll sort of sense that by how many people are in their seats. If you're planning on not coming back this afternoon, just let me know. It's totally cool. But just let me know so that we don't sit here and wait. Like, where is she? I knew she was coming back, and then she doesn't come back. So, yes.
You want us to log out of your servers?
I don't care. So the questions that you might have are, do you want us to log out of the servers? My answer is I don't care. The other question you might have is, can I safely leave my laptop here? My answer is going to be no, but I'm going to leave my laptop here. Right? Because what I don't want to do is take responsibility for your gear, because I'm not going to stay in this room. I'm probably going to go eat something also. But so it's up to you. If you want to be safe, if the thing you don't want to do is lose your laptop, you should take it with you to lunch. It might be hungry too. The playing cards that you have are your souvenirs and your certificates of completion, so you can keep those. If you want, if the thing you cannot stand is carrying one more piece of thing with you, you may leave your playing card with me. You can return it and put it up here, but it's cool. I would recommend not doing that until the end of the day in case someone shows up in the afternoon and wants to get caught up, and then they pick up your card and then they're stomping all over your stuff. Also, I've taken the stuff that we wrote and pushed it up to that GitHub repository. The stuff that we wrote is like the apache.rb file so far, but as we write more stuff, I'll push that up to the GitHub repository as well, so that at the end of the day, you'll have in that repository everything that we've touched. Sound good? Enjoy your lunch. If you're on the live stream, I'll tweet out a new live stream after lunch. So we're going to be back in about an hour.